Hello grade 12s and welcome to this lesson on an inverse of an exponential function. In this lesson, we determine the equation and draw the graph of an inverse of an exponential function. Let's join Karen as she introduces these concepts to her students.
We need to determine the inverse function of an exponential function. So where do you think we should begin?
I found those function machine diagrams you've showed us very useful.
And I found those flow diagrams and tables very easy to work with.
Well, here I have a diagram of the function machine for the function f of x is equal to a to the x. Here, x is the input to the function and f of x equals a to the x is the output. This is the input of the inverse. The inverse produces an output x, which is the same as the input of the function. We denote the inverse of f of x as f minus 1 to the x.
Using these flow diagrams, I can show the same idea. These input values would be acted on by the function to produce these output values over here. If there's an inverse function, then these outputs of the function will be the inputs to the inverse function, and the output of the inverse function should be equal to the inputs of the original function.
Instead of talking about a general function, let's focus on an example of a particular exponential function. F of x equals 2 to the x. Here is a table of values for the function f of x equals 2 to the x. The x values have already been filled in. Can you guys determine the value of f of x for each of the x values?
Okay, if f of x is equal to minus 2, then f of x is
f of minus 2, which equals 2 to the power of minus 2.
which is the same as 1 over 2 to the power of 2, which is 1/4. Then the next one would be if x is equal to negative 1.
Then f of x is equal to f of minus 1, which is equal to 2 to the power of minus 1, which is the same as 1 over 2 to the power of 1, which is equal to 1/2.
Okay, if x is equal to 0, f of x would be equal to 2 to the power of 0.
And anything to the power of 0 is 1.
That was really great work, guys. Here is a graph with a set of axes drawn on a grid.
Our first coordinates are minus 2 and 1/4.
The coordinates of the second point are minus 1, 1/2.
Our third point lies on the y-axis because our x-axis is equal to 0 and our y-axis is on 1.
And I can see where to mark the next point.
Very good. What does your graph show you then?
This graph plots out a smooth curve. It must be an exponential function.
Now we have a table of values and a graph for a particular exponential function. Now I've added 2 more rows to the table we used for the function. We can use these rows to develop the inverse function. The inverse will take the output values of the function, the values in the second row as input values. Let's fill in the values.
It won't take us long to write the input values for the inverse.
There, the values of the output of the function are the same as the values of the input of the inverse function.
That's right. The inverse function now takes the values that you've written down and acts on them to produce the input values of the original function as our output values.
Fine. So what we are saying is that the inverse of f of x takes this value, 1/4, acts on it, and produces minus 2 as an output.
The next thing we need to do is to draw a graph on a set of axes like we did before. We are now going to do the graph of the inverse function. Plot the points you've recorded in the table for the inverse onto the same set of axes where you've drawn the graph of the exponential function.
That shouldn't be too much trouble. Your first point is 1/4 on your x-axis and a negative 2 on your y-axis. And then your second point is 1/2 on your x-axis and a negative 1 on your y-axis. The graph now shows us the inverse function of f equals x.
Remember, we started this investigation with the intention of finding the equation of the inverse function. However, it is not as easy to determine the equation of this function from this graph as it was to determine the equation of the straight line graph. I think that we should look for another pattern between these functions first, a pattern that is best seen on the graph. The point 38 represents an input of 3 into the function and an output of 8 from the function. The inverse function takes the output 8 as an input, acts on it, and produces 3 as an output. On the red graph, it's represented by this point 8,3. Let's link these points with this line here.
That's a really interesting way to show how the coordinates of a function are linked to the coordinates of the inverse.
Thank you, Cindy. And you will soon see that there are two very interesting patterns developing here. Look, I've added in lines linking 2 more points. The point 24 on the function is linked to the point 42 on the inverse, and the point 12 on the function is linked to point 21 on the inverse. What do you notice about these pairs of points?
I see that in each pair of points, the point on the function and its partner on the inverse function, the x and y values, have simply swapped around. 3,8 has become 8,3, and similarly, 2,4 has become 4,2, and so on.
That's right, and we can use that observation to determine the equation of the inverse function. Watch what happens when I use that observation. Let's say that f of x is given by y equal 2 to the power of x. We are interested in the equation of the inverse. We can simply swap the y and the x around, and we get x equals to 2 to the power of y. But because we would rather have this in the form of y equals to something, we need to make some changes. In order to do so in this case, you need to be familiar with what are known as logarithms. We say that if a to the power of x is equal to b, then x is equal to the logarithm of b base a. In simple terms, the logarithm is the exponent of a given number that will produce the value that is wanted. So in this definition, if the exponent of a that gives b is x, then we say that x is the logarithm of b base a. Okay, so using that definition, we can now tidy up the inverse function f of x by saying y equals 2 to the power of x. Now the inverse for this exponential function is given by the equation y equals log of x to the base of 2. Can you see how to write the equation for other exponential equations? Take the equation f of x equals 3 to the power of x.
Then wouldn't the inverse of f of x equal log of x to the base 3?
Well done. Remember that the logarithm is acting like any other inverse and undoes what the function has done. Now let's return to the graph of the exponential function and the log function. There's something that I need to draw to your attention. First, I'll add in the remaining lines that link the corresponding points on the function and the inverse function. What I would like you to notice is that these lines are all parallel to each other, as well as all being perpendicular to this line y equals x here. We said that a reflection about a line takes each point of the shape to its mirror image with respect to the line. We can also show that the line of reflection is the perpendicular bisector of the line joining the original point and the reflected point. This means that the function and its inverse are reflections of each other about this line. This is a very useful property to know, and the one that Tebogo observed when he noticed that the points on the inverse function were simply the corresponding points of the function swapped around. So x becomes y and y becomes x. The approach of linking the function and its inverse by reflection about the line y equals x seems to have worked for the inverses of linear functions and exponential functions.
That was a good introduction on how to plot the inverse of exponential functions. Let's do one more example together. Here is the graph of y is equal to half to the power of x. The x-axis is the asymptote, which means that the function approaches it but doesn't cross it. Do you know what the equation of the inverse of y will be? Remember that exponents and logarithms are inverse processes. The inverse of our function y equals half to the power of x is y is equal to log of x to base half. Now let's plot the inverse on the same set of x's. Can you see that the y-axis is the asymptote of the inverse function? Thank you for joining us, grade 12s. Remember to look at the functions and inverses tasks video. You will also learn more about functions on our website. That's www.mindset.co.za/learn. Goodbye.